Welcome to Object-Oriented Programming course. Today's topic is encapsulation. The term itself might seem confusing, nevertheless it's quite self-explaining. We will go through several themes as intro to OOP, its advantages, and some ideas behind data abstraction and encapsulation. First of all, object-oriented programming is a concept of objects. Having your code divided into smaller parts as objects makes it more manageable and maintainable. Procedural programming is all about playing around functions where data is not that much important. The most important part is the sequence of actions to be done. It's more like linear programming, whereas OOP is nonlinear. It also eliminates reinvention. I mean, every object knows its responsibility, and the same object can be used for similar tasks. Therefore, it becomes easier to manage big applications. Let's discuss the difference between procedure-oriented and object-oriented programming. These paradigms differ from each other in what they take as a basis. If POP is all about having a program divided into tiny parts as functions, OOP is based on the concept of objects. Furthermore, the importance given to the data is the way more in OOP, since procedures needs to have a constant order of actions to be done. Access specifiers also takes place when we deal with objects. This everything helps us to create a program that is easier to extend. There are a bunch of language that lets us to do an object-oriented programming that starts from C++, Java, C Sharp, etc. Advantages of OOP are reusability, refactoring, extensibility, and efficiency. Let's stop at each of these points. Reusability. In the world of objects, or as we may call them as entities, each of them is in the interconnection with other objects for some apparent reason. That connections may be revealed in the usage of one object by another. Even though that some objects can be sufficient, most of them have dependencies over other objects. Later on, you will learn topics as data associations that includes aggregation and composition, or even advanced term as dependency injection. The question is, why should we create this or that object? Well, this is because every object can solve its own specific task, and whenever you face that task, instead of solving it yourself, let's say, from scratch, it's better to use already defined class object that can do it for you. This is exactly what reusability is about. Refactoring. Sometimes you as a developer might be asked to review the architecture and, where possible, refactor code to create smaller and more manageable components. OOP gives you the maximum benefit in here, since every object is such a small entity that has all its properties and methods as a part of itself. In ideal world, changing one code should not affect on another. I mean, it should not force you to make any change on unrelated class. That's why one of the most difficult part of OOP is to divide every logic into objects properly, since it's a common mistake when a programmer expects from a class a bit more than it should do. That's how fat classes are born. Extensibility. That's actually the most remarkable advantage of OOP. A class can be created based on another class that can be called as inheritance or extension. Let's imagine we have two classes as student and person. A student has an ID, name, and surname, as well as any person. So instead of doing redundant code repetition, it's the way better to create a class student that extends person. Being a person for student will not constrain from anything. It could expose new features or override existing one. The last one is efficiency. The OOP concept itself is in fact developed for efficient coding and gaining the simplicity in the development process. The core idea behind that is to divide and conquer. Once you've got a big problem, you need to split that into smaller ones, and solving each of that tiny problem will slide you to the end of solution for initial problem. Alright? Key principles for every program, class or method, for whatever you've got as a code are dry, which is don't repeat yourself, and KISS, which means keep it short simple. Sometimes keep it stupid simple. Here's an illustration of badly designed class. None of the conventions were kept. A function should do one thing, the name of variables, classes, methods must express itself. Actually, whole code must be kind of screaming. What should your code scream about? Of course, about what it in fact is doing, or for what reason it exists. So let's start all over again. Assume that you are about to create a class. You need to have concrete answers for questions like why this class must exist, what you expect from that, what should be the state of that object or how that object should behave, and the last question, should that object behave like that? You are asked to create every class so that you won't lose any of that OOP advantages. Let's talk about reusability. Do you believe that this piece of code is quite reusable, or does it solve only one concrete problem? In this case, we should eliminate hard coding. Hard coding can appear not only inside your code, but even in the logic, in the way you solve the problem. Data abstraction. Focus on the meaning of the operation, behavior, to avoid overspecification. The key idea is about layering your code and program in abstract level. I will explain. Let's say you have a method that does something. We are not asked to write the whole implementation inside that unless it's needed. We must think of real implementation. We can call that low-level coding as kind of background details. All right. So real implementation, like low-level coding, it's kind of background details. Data abstraction teaches us how to hide that unnecessary details from outside world, leaving only essential information about the data. The representation details are confined to only a small set of procedures that create and manipulate data, and all other access is indirectly via only these procedures. In example, sort function. We do not need any information of how this function is implemented, which algorithm it uses to sort, or maybe it uses some other background services. All we need to know is just what that method does. Data abstraction also helps us to write readable code, because a code must be polite. I mean, we should think of a reader as well. It's the same as in journalism. If you read any article, it starts from heading, then the abstraction, that is human readable part of an article. If you go further, it goes deeper and deeper to the details of that article. It's written in that way since they let the reader to exit at the right time. Once the reader understands that it's not interesting anymore, so it can exit from any part of that article. The same should appear in our code. Encapsulation principles. The core idea of encapsulation is wrapping the data and code acting on that data together as a single unit. If we think of an object, can that be accepted as a single unit? For sure, yes. Since an object controls the visibility of its items, I mean, properties and methods and provides kind of API for an outside world that reveals the behavior of an object. To ensure proper encapsulation, all data in class must be hidden from other classes, and the communication process can be made through methods. Therefore, it's also known as data hiding. So what is data hiding? It's one of the important features of OOP that allows preventing functions of a program to access directly the internal representation. In simple words, one object cannot directly manipulate the state of another object. That is done using access modifiers within a class, which specify the access restriction. The data hiding can also be seen when we call a method. A programmer does not need to know the details of the code in the body of that method. Sometimes one method works in conjunction with another private method. Well, it's considered as a good programming practice to make all properties of a class to stay private, which means that they cannot be accessed from outside world directly. As we told before, at least it is a good start during class construction. If there's a need to have an indirect access, then we create public accessor and mutator methods like getter and setter. Making that methods to be public, it's also just a good start. Sometimes, but not often, some other access modifiers can be used for that methods. To sum up, encapsulation describes the idea of bundling data and methods that works on that data within one single unit, which means that object state and behavior is wrapped together. Direct meaning of this term is drawing a boundary around something.